Time period of a pendulum is the time taken to complete one full oscillation from one extreme position to the other and back again. Time period is equal to 2 pi under root length of the pendulum divided by acceleration due to gravity. Time period is independent of the mass of the bob. Even though the masses of the bobs are different, their time period is same. Now let's measure the time taken to complete one full oscillation. Start. Stop. Time period is 2.4 seconds. The length of the pendulum is 1.43 meters. If I substitute appropriate values of L and G, I would get the time period of this simple pendulum. T equal to 2 pi root 1.43 by 9.81. The answer is 2.40 seconds. Pendulum with a greater length has a longer time period. The length of the second pendulum is 1.95 meters. Let's measure the time taken to complete one full oscillation. Start. Stop. It is 2.80 seconds. You can verify that using the equation. Acceleration due to gravity on moon is 1.625 meters per second square. Time period increases as the gravitational acceleration decreases. Time period of the first pendulum is 5.89 seconds, whereas that of the second pendulum is 6.88 seconds. Start. Stop. Time period is 5.89 seconds. On the moon, where gravity is weaker than on Earth, a pendulum would swing slowly, taking longer time to complete one oscillation.